Today we're looking at bioassays from Pubchem, Pubchem Part 2. You can look at compounds from Pubchem, the Part 1 video if you're interested. But this Part 2 video is looking at the Pubchem brick, specifically bioassay data that's distributed through that brick. So we're talking about BioBricks.ai, which is a system for distributing data. And in this case, we're talking about the Pubchem brick that it distributes. So we're going to answer questions like, what is the most tested compound on Pubchem? Without further ado, let's pull up the code. So if we're working with Pubchem, we can install Pubchem by running BioBricks install Pubchem. Before we do that, if you don't have BioBricks yet, you can pip install BioBricks and then configure it with BioBricks configure. If you want more information, you go docs.biobricks.ai. But yeah, let's go ahead and do BioBricks install Pubchem. This is going to install really quickly for me because I already have it, but Pubchem is actually a couple hundred gigabytes, so usually that step would take a little bit longer for you. Okay, so now that we have Pubchem, we can start at an R environment, and I've pre-computed some things in here so that we can move a little bit faster, but you can pretend that I'm live coding if you want. So basically, we're going to load the BioBricks client and tidyverse for manipulating tables a little bit and plotting, and we're going to pull in Pubchem with this line, PC is BB load, Pubchem, and we see the PC list that results from that call has two assets, compound SDF and bioassay concise. Where's that data coming from? Well, if we go to the NLM FTP, we can see that it has a whole bunch of directories in it. In this case, we're in the Pubchem bioassay concise CSV directory. And you can see there's a data directory there. This is where we get all the data for this asset that we're distributing through the Pubchem brick. And yeah, so we've got bioassay concise, and we have BA here. So we assigned BA to the result of basically collecting that whole table into memory. You do need a good amount of memory to hold this table. So this machine has kind of a lot of RAM, 48 gigs of RAM to run. This is the only thing that's running right now, in addition to the video recording software. So let's see what that table looks like. We can see that it has assay IDs, has Pubchem result tags. This is like a row number. So like these top three rows all correspond to the same bioassay, the same test result. And you can see that the assay ID is 1 and the tested substance is 66954, which is the same as the compound 11122. And you can see the smiles for that substance right here. This is like the chemical structure for the tested compound. And then you can see there are two more columns, property and value. So what do those two columns look like? If we filter out a few of in the middle columns, we can see SID, Pubchem compound ID, we have properties and values. The property we're going to focus on today is activity outcome, but you can see that for, let's go ahead and add, what was it? Pubchem result tag. So if we add result tag back in here and run this again, we can see that the top three rows correspond to one test, and that test has multiple properties and values associated with it. And so Pubchem activity outcome, the outcome of this test was inactive. So this compound was inactive for this assay when it was tested. And that's what we're going to focus on today. So how many results are there here? That's about 500 million results, 570, 682, 157. Yeah, almost 600 million results. But those aren't 600 million assay results because, there are multiple properties for each assay. Okay, so if we're interested in knowing, what is the most tested compound, we can go ahead and run this query. We can take our table, we can group it by the Pubchem compound ID, and then we can count the number of distinct assay IDs for each compound ID, arrange it by the descending number of those distinct assay IDs, and just take the top one. And I've already computed that. That would take quite a while to compute. If you're on a computing cluster, it'd be a little faster. So we can see the result is Pubchem compound ID 2764. And it would go ahead and look that up. 2764. I don't know if that works. I think that works. Yeah, there it is. The result is ciprofloxacin, which is an antibiotic. It's commonly used antibiotic. Okay, cool. So that's the most tested compound, and that's something we can pull with the we can learn about quickly by pulling the Pubchem data with BioBricks. Yeah, and if we want to look at the URL, this would have worked a little bit easier. We generate the URL and see the compound. So what other questions could we answer? Well, we have a bunch of assays. We might ask like, how many compounds do the biggest assays test? And we could do that this way. So we could take the bioassay table, filter it down to just the property Pubchem activity outcome. Maybe we also want to know, like how many active and inactive results do those assays have? Make the table a little bit more interesting. And then we can count the total number of results for each of those as well. So this first paragraph, if you want to call it that, is just filtering down this table, this BA table, to property results that have Pubchem activity outcome. If we look back here, we can see, we're filtering this down to property is Pubchem activity outcome, and we're collecting the values here. So we're counting the assay ID, the number of rows for a given assay ID and a given value where the property is Pubchem activity outcome. We're also just counting the total number of rows, the total number of tested compounds for each assay ID in this next group. So get this total value. So this would also take quite a while to compute, and I've done that already. And so we can see that, some of these top tested ones have quite a few test results. And you can see it's arranged in this case, from assay ID 1 down. But if we wanted to arrange by total, we can take like the top 100 assay IDs by this total number, and we get PDF here, which stands for plot data frame. And we can see that these really big assays have like hundreds of thousands of tested compounds, and maybe like 10% or so, 1% or so of these top few of assay ID 1508602 are active, and the rest are inactive. So we can create a quick plot from that. I'm going to start an HGD server to, show my ggplot figure here. I'm going to create that ggplot figure, and we can take a look. And sure enough, we see a bunch of the bigger assay IDs, the bigger tests on Pubchem with hundreds of thousands of test results. We might be interested in this one, let's say 686978, just because it has like a large number of actives. So what is that one? Let me pause for a second while I try to remember what the URL looks like. There we go. So the URL is pubchem.ncbi.nlm.nih.gov/bioassay. And if we get the URL, if we get the number for this one, it's 686978. So let's pull that up. And there you go. Quantitative high throughput systems for inhibitors of human tyrosine DNA phosphodiesterase 1. So something that's modifying DNA. I don't really know. TDP1, QHDS in cells in the absence of CPT. And you can see, sure enough, there's hundreds of thousands of tested compounds here. It looks about 10% of them are active, and a whole bunch of inactives. And yeah, cool. So I think that probably aligns pretty closely with what we see in this plot. All right, great. So that's part 2 of this series. You saw in part 1 how we can pull compound data, count molecular weights. In part 2, we're looking at bioassay results. And part 3, if we get enough likes, we'll go ahead and do Pubchem RDF, which is a really interesting asset distributed by Pubchem. I think RDF stands for Resource Description Framework. But anyways, it just has a whole lot of information about other kinds of things like reactions or relationships to genes. And yeah, I hope you find this interesting. If you do, give it a like, and we'll keep going.